Okay guys, now in the second part of this introduction, it says a polynomial is factored completely when it is expressed as the product of a monomial and one or more prime polynomials. Okay, so we're just trying to break this thing down as much as we can. Like breaking down the number 12. 2 times 6, that's prime, I'm done. But this can be broken down again to 2 times 3. Now all of these things are prime. It's sort of like we're doing a factor tree for polynomials. Okay, now the first thing we want to do is we want to look to see if we can factor out the greatest monomial. Is there anything that goes into all of the terms that I can pull out front, right? Okay, that's what we want to look for first. All right, now after we do that, we want to look for some easy stuff, like, is this the difference of two squares, right? A squared, a squared minus b squared. Is it something that looks like that? Or the third thing, is it something easy like the perfect square trinomial? That's possible. Look to see if the first number is a perfect square and the third number is a perfect square, right? And then I've got 2ab in the middle, right? Look for that kind of stuff. That's some easy things. If it's not a square, look for a pair of binomial factors. That's the first thing that we saw if we could do. Can I factor it into two binomials, right, that multiply to give me the polynomial? Okay, now here's a key one, and this is one we haven't done yet. This is one that works with grouping, like the stuff that we were talking about in the first part of the introduction. If a polynomial has 4 or more terms, 4 or more, look for that. 4. Look for a way to group the terms. Okay, now today we're going to talk about grouping them into two terms, right? Let's say if I had let's see, a cubed plus a squared b plus a b squared plus b cubed, something like that. Okay, then I might want to group them into two terms like that, one here, one here, one here, one here, or I could actually group them. Now why did it do that? B squared plus b cubed. I might want to factor them into 1 and 3. All right, 1 and then try to factor this thing. All right, because we know how to factor 3 terms. Okay, so we're going to look at problems, an example of each one of those in grouping. Okay, and then always going back, do I see a difference of two squares? Is there something that I can pull out? Is this a perfect square trinomial? Even after we've done some other factoring, okay? Keep looking to see if you can factor any more, okay? Then the last couple of things, 6 and 7, it just says, make sure the binomial or the trinomial factor is prime. If it's prime, then leave it, okay? And then you can check by multiplying out the factors to see if you get what you started with, all right? So we want to factor, look for things. Is there anything I can pull out? Is it a difference of two squares? Is it a perfect square? Can I factor it just into two binomials, right? Do I need to group some things? All right, always factoring until there's nothing left for us to do. Okay, let's take a look at some of these examples. Good job, guys.